Welcome. This video will be about the domain of functional operations. Finally, the domain of the sum, difference, product, and quotient of two functions are stated as this. If f and g are functions, then the domain of the functions f plus g, f minus g, and f times g is the intersection of the domain of f and the domain of g. The domain of f divided by g is also the intersection of the domains of f and g, with the exclusion of any x values for which g of x is equal to 0. Restated, the intersection of domain of f and g with the exclusion of any values that would make the denominator 0. So let's find the domain of f, g, the sum, difference, product, and quotient of the two functions. First, I have a function f of x is equal to 7x minus 2, and g of x is equal to 4 minus 8x. Now remember, the domain of any function is stated to be all real numbers unless the variable is located underneath the square root or located in the denominator. Therefore, if I'm looking for the domain of f, and I notice that the variable is not located in the denominator, then my domain is going to be all real numbers, which can be rewritten as negative infinity to infinity. Same thing with g of x. I notice that the variable is not located underneath the square root or located in the denominator of the function. Therefore, its domain is also all real numbers or from negative infinity to infinity. When it comes to finding the domain of the sum, difference, or product of two functions, then we're looking for the overlap of the two domains. Since both domains f and g are all real numbers, then we can say that their overlap will also still be all real numbers. F minus g and f times g, along with f times f, should all give you the same domain of negative infinity to infinity. The concern that you have with the operational domains is when you have a function located in the denominator. So for f divided by g, we need to first look at what that function looks like. And that would be f of x over g of x. And we want to know what would make g of x equal to 0. Therefore, x cannot be 1/2. Therefore, its domain is going to be everything but 1/2. Similar, you can be said about the function g divided by f. If we take a look what the function looks like, it is g of x over f of x. And we want to know what would make the denominator 7x minus 2 equal to 0, and therefore x cannot be 2/7. Therefore, your domain is going to be everything but 2/7. Now for the next set of functions that we have, we still are looking for the domain of f, g, the sum, difference, and the product and quotient of the two functions. But now f of x is the square root of x, and g of x is equal to the square root of 2 minus x. In order to find the function of f, we need to take whatever's underneath the radical and set it greater than or equal to 0, which means that its domain is going to be from 0 to infinity, including 0. For a visual illustration, let's do a number line. Now to find the domain of g of x, we need to take whatever's underneath the square root and set it greater than or equal to 0 also. And this means that the domain has to be from negative infinity up to positive 2. So we found the domain of each function and did a visual graph of it. For us to find the domain of f plus g, it is best if we take a look at the number line and find out between what two values do the graphs overlap. And you can see that they overlap between 0, and 2. Therefore, your domain is going to be 0 to 2, including both points. Same thing for subtraction, and same thing for multiplication. When it comes to f multiplying to itself, even though when you have the square root of x times the square root of x canceling out, giving you the absolute value of x, we still cannot change the original domain of f. Therefore, its domain is still going to remain bracket 0 to infinity. Even though the answer no longer contains a square root, you cannot add values to the answer that were not initially there in the original. Now let's find the domain of f divided by g. Now let's go ahead and take a look at what the quotient will actually look like, where I put f of x on top and g of x on bottom. Now your domain of the numerator is still going to be from 0 to infinity, but what's the difference about the denominator is the fact that normally we would set it greater than or equal to 0, but because the square root is in the denominator, it cannot be equal to. So therefore, when we look at the overlapping domains, and it's going to be from 0 to 2, we cannot include the 2 because they would be in the denominator. Therefore, we have to put a parentheses there. And to find the domain of g divided by f, let's look at its original quotient of the square root of 2 minus x over the square root of x. It's the same thing here. The denominator cannot be equal to 0, so therefore we cannot include it in the domain. Now in the previous problem, we just learned how to find the domain of a square root, and that's by taking everything underneath the square root and set it greater than or equal to 0. Now in terms of a fraction, the best way to find the domain is by taking the denominator and set it equal to 0. And that number cannot exist in the domain. So therefore, your domain of this problem is going to be everything but negative 5. Same thing can be done for g of x. In order to find its domain, you take whatever the denominator is, set it equal to 0. And that number cannot be part of the domain, so it's going to be from negative infinity up to 3, then from 3 to infinity. So what I want to do is I want to do a number line showing what it would look like if I did a number line for the domain of f of x. It is going to be where negative 5 is not included. And I'm going to do the same thing for g of x. So when it comes to finding the domain of the sum, difference, and product of f and g, then we know the domain will not include the negative 5 or the positive 3. So your domain is going to be from negative infinity up to negative 5, between negative 5 to 3, and then from 3 to infinity. When it comes to f times f, it only affects the domain of f. Therefore, since f does not include negative 5, its domain is going to be from negative infinity up to negative 5, and then from negative 5 to infinity. When it comes to finding the domain of the quotient f divided by g, it's the best to take a look at what the original quotient looks like, where we put f of x of 6 over x plus 5 on top of g of x of 1 over 3 minus x. That simplifies to be 6 times 3 minus x over x plus 5. If you only take a look at the answer to find the domain of this quotient, then you would only think that negative 5 would be not part of the domain. But remember that g of x is actually located in the denominator, and therefore g of x cannot be 3. Therefore, the quotient cannot be either 3 or negative 5. So we need to include those two numbers. And finally, let's find the domain or the quotient of g divided by f. Again, it might be best to look at what the original function would look like, where I put g of x on top of f of x. And that simplifies to be x plus 5 over 6 times 3 minus x. Again, if you only look at the answer to determine the domain, you may think that 3 is the only thing that x cannot be. But remember that f of x was actually located in the denominator to begin with, and f cannot include negative 5, so therefore the domain of g divided by f, again, cannot include negative 5 or positive 3. In the following problems, consider the function f and g as shown in the graph below. We want to be able to find the domain of f, g, and the sum of f plus g, along with the domains of the difference, the product, and the quotient of f divided by g, and finally the domain of g divided by f. First we want to find out is, when does f start? F starts at positive 2, and it ends at positive 11. Because both endpoints are closed, you include those endpoints. For g of x, which is the blue line, it starts at 1 and it stops at 9. Again, both endpoints are closed, so therefore I include those endpoints. When it comes for the sum, difference, and product, we're looking for the overlap of the two domains. Therefore, when do you see f of x on top of g of x? You see it between 2 and 9. So f plus g, f minus g, and f times g should all have the domain of 2 to 9, including each numbers. Now what makes f divided by g different is the fact that we want to know, when we put f on top of g, where is g equal to 0? Does it cross the x-axis? And the blue line does not. Therefore, your domain is still going to be between 2 and 9. But when you flip that, when you want to find g divided by f, and that is where you're taking the g divided by f function, we want to know, where is f equal to 0? Does it cross the x-axis? And if you look at the function, it does cross it at 3. So we cannot include that in the domain. So how do you remove a number that is inside an interval notation? By using parentheses. So we're going to go bracket 2 to 3 parentheses union 3 to 9 bracket.